I had a ton of fun implementing the real-time visualization in D3, and I hope you explore and extend this functionality in your final project if you're interested. Also, remember that Udacity's course Visualization Using D3 could be super useful to take if you want to expand on this brief introduction. Let's explore the basic D3 implementation by navigating to the app.py file. Scrolling down, note that the decorator function at app.route/basic and function show_basic calls the render template method on the basic.html file. Navigating to the templates folder, you see a few files that you should be familiar with if you completed the optional personalization exercise in lesson 1. We navigate to the basic.html file, and inspecting further, we see that our D3 files are loaded via this source file, and our second source file is under static/app.js. We scroll down further to the body and script tags, where I've defined a variable colors and variable SVG container, which stands for Scalable Vector Graphics Container. This uses D3 methods to select the body and appends an SVG element with the given attributes. This is the SVG container that is updated in our app.js script to visualize our tweets. Remember, if this HTML and JavaScript section is interesting to you, you can always explore this in much more detail in an HTML and CSS class, JavaScript course, or our Data Visualization with D3 course here at Udacity. We then navigate to the static folder and open the file app.js sourced in our basic.html file. We also see a familiar stream path that was defined in app.py. And if we navigate quickly to app.py, we see the stream path and function response and event stream. And finally, the event stream is connecting to Redis and the pubsub.subscribe function to the word count topology connected to our publish function in our Storm report bolt. Navigating back to app.js, notice that I'm using an event source constructor. You can read about event source further by clicking on the Mozilla link provided in the instructor notes. And you can search for the onMessage attribute. This takes an event, which is again a message received from our Redis subscribe method, and splits the method by a pipe character. Let's again link this back to the syntax that we used in our report bolt storm topology. Navigating to any report bolt, we see that we have a word separated by the pipe character and the count. Navigating back to app.js, we see that at position 0, we define our word, and at position 1, we set our count. Next, using the JavaScript associate array, which I've named hash, I simply set the word equals count. Notice that I have another skip word check, but this can be removed after completing lesson 3 top n words with filter. And by now you should see that filtering at this late stage in our data flow is very inefficient. Remember to always filter as early as possible in your topology. Scrolling down further, we finally come to the real D3 syntax that I've entered into an update viz function for timing purposes. We define a new variable text that takes in the SVG container and the D3 select all with text attribute. Notice there are none to begin with, but they will be created by D3. We then bind our data using the D3 entries function on hash. This entry function is great in that it takes a word count association and transforms it into a keyword value count association. And this is the form that we are using throughout the rest of our D3 functions. Additional information along with a great tutorial can be found in Michael Bostock's selection page included in the instructor notes. Next, we enter this data by calling the text.enter function and append text with the given attributes. Again, following Michael Bostock's example, I followed the selection.text with value syntax by calling the text with an added word by using the d.key notation. And remember that key maps to word coming from Storm. Now that our text is the word coming from Storm, I added a few fun transitions, delays, and explicitly tried to demonstrate how the X and Y positions can be set using the d.value, which is again our count coming from Storm, along with the position order that the word count comes in our associated array. Next, again for fun, I updated the font size to be linked to, again, the value, which is the count, and finally the fill color, using our colors variable, again linked to count and now position. A fun demonstration of this can be seen by going to the /basic location, and I'm running the solution from lesson 2, stage 4. Notice that in the random sentence word count, as each word count is updated, we see them moving in the Y direction, changing colors with transitions, and growing in size. We can play along with this more by going into our app.js and commenting out the previous line and uncommenting out a different fill function. We save our app.js file, but we don't need to recompile our Storm topology. And after refreshing the page, we see that the color palette has changed to be a smooth transition to a dark red. We can play along with this further by removing the dependencies on the order that the words show up in our associative array by deleting our I variables. And we see now the X and Y position is controlled only by the count, and the two words in the lead are and 7, which are overlapping. Notice that it's really simple to simply save and refresh in Chrome, and we don't need to rebuild our Storm topology. This makes iterating on visualization super fast and easy. So play along with this if you like, and maybe use some of these ideas in your final project visualization if this interests you.